Hello guys. Hello everyone. Just tell me if I'm audible and my screen is visible to all guys. Just tell me in the chat box, please, fast. Whether I'm audible and my screen is visible to everyone, please tell me in the chat box. Am I audible to you guys? Just tell me in the chat box. Am I audible and my screen is visible to you? Tell me, guys. Tell me in the chat box. Fast. Okay, so shall we start or should we wait around 1 to 2 minutes so that everyone can join? Just tell me. Okay, so I think we should start now. Let's start the session. So, hello everyone, welcome to the GDC English YouTube channel. So, in today's Mahamarathon session, what we are going to discuss, we are going to cover the complete syllabus of the organic chemistry and we will discuss 50 important MCQs of the complete syllabus of organic chemistry, and this is the part of our Mahamarathon series in which we are discussing total 4000 MCQs. Okay, so today we will cover the MCQs from the various parts of the organic chemistry and along with we will learn some new concepts. So let's start the session. Okay, so the first question that comes in our is what? In order to overcome the angle strain. Okay, so share your answers in the chat box, guys. So the first question is saying that in order to overcome the angle strain, cyclohexane acquires. Okay, so we know that the to overcome the angle strain, what does the cyclohexane have? The first option is your square planar structure. The second option is your planar structure. The third option is your puckered ring structure. And the fourth option is what? Pyramidal structure. So we know that initially, as per the pair strength theory, the cyclohexane have lower stability, but instead of that, the cyclohexane has the higher stability. Why? Because of that, because it has what? It has a puckered ring structure and it gives the more stability to cyclohexane because it due to the puckered ring structure, what it's getting? It's getting the non-planar structure. It having a non-planar structure and due to which the cyclohexane have the higher stability. And this concept was given to us what? This concept was given to us by the Sachet and Moore. In which theory they have mentioned it? The theory is known as your Sachet and Moore theory. So this concept was given by Sachet and Moore, and the theory is known as your Sachet and Moore theory. Okay. So this was the so option number C will be your right answer. The correct option will be option number C, that the cyclohexane possesses what? Acquires what? Puckered ring structure in order to overcome the basic angle strain. Okay. So in order to avoid the strain, cyclohexane does not exist as a planar molecule. It does not exist as what? As a planar molecule, as it has expectation that it should exhibit at as a planar molecule, but it doesn't. It exists as a puckered ring structure which is non-planar and bond angles are close to tetrahedral bond angle, and two puckered ring that form the cyclohexane are boat and chair conformation. Two puckered ring that form is known as boat and chair conformation. And who has given us this theory? The Sachet and Moore has given this theory. So that's why it is known as the Sachet and Moore's theory. Okay, so remember this point. That's why the cyclohexane have a higher stability. Next question. So conformation of the cyclohexane, we can see that sachet and more assumed with a non-planar or puckered folded forms of cyclohexane, and these are what? These are the chair and boat conformations, which are free from what? Which are free from angle strain. This is the your chair stable, that is more stable. The most stable form is what? Your chair form. Then after that your twist boat form, then your boat form, and at last the least stable form is your half chair form is the least stable. Okay. Now let's move on to the next question. That is question number second is a type of your assertion reason type question. What is the question number second is saying that assertion carbon ions have a pyramidal shape like ammonia. This is saying that the carbon ions have a pyramidal shape like ammonia. Yes, this is what. And also the carbon atom carrying the negative charge has an octet of electron. Okay, so the assertion is that carbon ion has a pyramidal shape like ammonia. Yes, it's right. The carbon ion have a pyramidal shape like ammonia. And the reason is saying that the carbon atom carrying a negative charge has an octet of electron. Yes, reason is also correct. It has an octet of electron, but whether the reason is the correct explanation of your assertion is no. The reason is not explaining the reason behind. If you read the reason carefully, that it's saying that the carbon atom carrying a negative charge has an octet of electron. Does it have anything to sharing that it is related with the pyramidal shape of like of ammonia? No. So the assertion is your correct, but reason is your not the correct explanation. Both assertion and reason are correct, but reason is the not the correct explanation of your assertion. That's why what will be the right answer for this question? The option number B will be the right answer. That is, both assertion and reason are true, but the reason is not the correct explanation of the assertion. Okay. So alkyl carbon ion have a pyramidal shape like ammonia. That we can see that this is your carbon ion and this is the ammonia. Both have which type of shape? Both have pyramidal shape because ammonia and alkyl carbon ion have what? They both have a lone pair of electron on their center atom. It makes them negatively charged on the center atom, and which will acquire the shape of what? Which will have the shape of pyramid, that they have a pyramidal shape. Therefore, both assertion and reason are correct, but reason is not the correct explanation of your assertion. Okay. Now, so next question, question number three, again a assertion reason type question. So these assertion reason type question often gets confused. Most of the students get confused in this type of question. But how to solve this? In order to solve this type of assertion and reason question, you should have what? You should firstly read the question very carefully. Like read the assertion very carefully, then identify whether the assertion is correct or not. Then read the reason carefully and identify whether the reason is correct or not, and then go for whether the assertion, whether the reason is correct explanation of an assertion is not. So the first is your assertion, that is Friedel-Crafts reaction is used to introduce an alkyl or acyl group in benzene nucleus. Okay. So what they are saying that we know that Friedel-Crafts is what? There are two types of Friedel-Crafts reaction. First one is Friedel-Crafts alkylation. The second one is your Friedel-Crafts acylation. So in alkylation, they introduce what? Introduction of alkyl group to the benzene nucleus, and in acylation, the introduction of acyl group to the benzene nucleus. So your assertion is very good. Assertion is correct. Next one is your word. Benzene is a solvent for the Friedel-Crafts alkylation of bromobenzene. No, benzene is you act as a solvent. No, benzene is not acting as a solvent. Benzene is what? Benzene is acting as a receptor in which reactant. Benzene is acting as what? Benzene is acting as reactant. So your assertion is right, but the reason is your wrong. So assertion is correct, but the reason is wrong. Both assertion and reason are correct. No, option A will not be the right answer. Option B, both assertion and reason are correct. No, option B is also not the right answer. If assertion is correct, but reason is incorrect. Yes, your assertion is correct, but the reason behind that is incorrect. So option number which will be the right answer, that is option number C will be the right answer. That is your assertion is correct, but your reason is incorrect. Okay. Yes, we use what? We use the Friedel-Crafts acylation reaction for introducing the alkyl or acyl group, as we have seen. But the reason is not true, because if benzene was used as a solvent during alkylation, benzene will be alkylated in preference to the bromobenzene. That's why the bromobenzene reaction cannot be takes place. Okay. So the correct option will be assertion was true, but the reason was not true. Okay. So this is the main behind the Friedel-Crafts alkylation and acylation, and this is very, very, very important. Your Friedel-Crafts alkylation and acylation is very important, and I will recommend you to remember all the name reactions that are present in the organic chemistry is very important, guys. You should remember that. Okay, so Friedel-Crafts alkylation, then alkyl group in place of bromine, and here in acyl group is in place of hydrogen. Okay, so strongly deactivated benzene derivative do not give the alkylation. That's why I am saying that the questions are very important, but the your explanations are also very important, because with the help of explanation you will be able to recall new concepts, and at this time there is a high need that you should guys to recall the new concepts. Now, next question. Again, assertion reason type question. Question number 4. What the question number 4 is saying that in assertion is saying that SN2 reactions of an optically active aryl halide with an aqueous solution of KOH always gives an alcohol with opposite sign. Okay, what are they? And as reason is saying SN2 always proceed with the retention of configuration. So the first option is what? The first is SN2 reaction of optically active aryl halide. We have to do the SN2 reaction of an optically active aryl halide with what? With an aqueous solution of KOH. And what will it give? It gives an alcohol with opposite sign of rotation. Okay. So, no aryl halide. So first thing is aryl halide. So should aryl halide go for the SN2 reaction? Tell me guys. Tell me in the chat box. Like should aryl halide will go in the what? In your SN2 reaction, for example, if we talk about the aryl halide, like if we talk about like this, just simple like this. If we talk about bromine, then there will be what? There will be a partial double bond character. And due to this partial double bond character, these aryl halides will not go in the SN1 reaction. So assertion is your what? Assertion is wrong. Again, the reason is saying what? The reason is saying SN2 reaction always proceed with a retention of conversion configuration. That is correct. Assertion what? SN1, SN2 reaction always proceed with what? They will always proceed with the inversion. No retention. SN2 reaction always proceed with inversion. So that's why both your assertion and reason both are the wrong. Okay. So the correct option will be your option number D. That is both assertion and reason are incorrect. Yes, I'm getting the right answers in the chat box also. So both assertion and reason will be your incorrect. Okay. Now, next question. What is the question number? Assertion. Let's understand some explanation. Like assertion is false because aryl halides do not go undergo nucleophilic substitution reaction, as I have told you guys. Now, reason this is due to the resonance carbon chloride. They will not go under the what? They will not show the aryl halide will not show the SN2 reaction, and SN2 reaction proceed with the inversion of configuration. They don't proceed with what? They don't proceed with the retention. So the option was D will be the right answer. Okay. Now, next question. What does the question number 5? Again, question number 5 is saying which of the following fact explain as to why para-nitrophenol is more acidic than phenol. Okay, so what was there? The first one is your phenol. If we talk about like this is your what? This is your phenol, and this then again one is what? Again is your para-nitrophenol. Okay, so this one is your what? This one is your para-nitrophenol. So phenol and para-nitrophenol. So what they are saying that para-nitrophenol is more acidic than phenol. What is the there? Para-nitrophenol is more acidic than phenol. The first one is minus I effect of nitro group. Yes, minus I effect group. This nitro group will show what? This nitro group will show your minus I effect as well as minus R effect. So the first option will be correct. That is minus I effect of nitro group. Greater the resonance effect of para nitro phenoxide group. Yes. Minus R, that is greater the resonance effect. Yeah, that's also steric effect of bulky nitro group. No, steric effect will not act here. So the your first and second option will be right answer. That is your minus I effect of nitro group and your greater resonance effect of para-nitrophenoxide group. So the correct option will be what? First and second, that is option number A. These are the reasons why para-nitrophenol is your more acidic than the phenol. So the correct option will be your option number A. Okay, so first and second. Now, para-nitrophenol is stronger acid than phenol. Why? The nitro group is an electron withdrawing group, and the presence of this group as ortho para position decrease the electron density of the OH bond, and as result to what? It is easier to lose the proton. That's why the ortho and para-nitrophenols are always stronger acids than the your phenols. Okay, so that was the right answer. Now, next question. Again, question number 6. 6 is very interesting question. What is the question number 6 is saying that 6-methyl but I react with what? React with your mercuric acetate in presence of water to form a product which on reduction with NaBH4 Okay, so this is a type of step reaction. They are showing that two-step reaction. What is that? So 3-methyl but They are saying that 3-methyl but So let's understand it. What? CH3 C then your CH3 okay and CH. So 3-methyl but now they are showing that it reacts with your mercuric acetate to of in presence of water to form a product. When it react with what? When it react with mercuric acetate in presence of water, what will it form? When it will form simply like this. It will form, the initial step was what? Initial step was like, initially they will form like this compound, like CS3. First, the first reduction will be there OH and CS3, and after that here one more CS3 will be there, OH. So, and then further reduction, they will form what? They will form CH3, CH3. Well, CH3 will be there, and after that there will C double bulk O and CH3. This will form. So, now after that, when this product, when your final product will be what? CH3, CH3, C double bond O, CH3, and one more CH3. Now they have said that this product gets react with what? This product will react with NaBH4. Now when we will react this with what? They will have to react this with NaBH4, and NaBH4 will do what? NaBH4 will do your reduction, and after that reduction, this will be conversion of what? CH3, 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 and this double bond oxygen will converted into COH. So what will be the right answer? 3-methyl butene. So the correct option will be 3-methyl butene. Okay, so 3-methyl butene, sorry, butene. Yes, 3-methyl butene. That is option number third will be the right answer. Okay, so sir of MCQs. Yeah, I'm completing MCQs from the complete syllabus. We will cover the MCQs from the complete syllabus of the organic chemistry. Okay, okay, okay. No need to afraid. You guys will do a best in the examination, because you guys are preparing a lot. So just since it is only 1 week left, so you don't need to get panic. You have to be strong and you have to focus on your preparation, because you have prepared well and you will get a very good rank in the exam. So these are the last minute revision points. So just understand these points and you will get a very good rank. So don't panic or don't get afraid. The exam will be very good. Okay. This was the your reaction when 3-methyl butane, then in presence of mercuric acetate and NaHBr4, it will form what? 3-methyl butane 2. Okay. Now, next question. Aldehydes that do not go under the aldol condensation. Okay. So, what is the reason? In order to get the aldol condensation, what we have understand? We have understand that there should be what? There should be alpha hydrogen. So, if no alpha hydrogen, it means no aldol condensation. There should be alpha hydrogen. So first one is your what? The first one is your propanol. That is, for the propanol, it has 3 alpha hydrogen. For propanol, 3 alpha hydrogen. Then the second one is your what? The second one is your trichloroethanol, 0 alpha hydrogen. Again, third one is your methanol, 0 alpha hydrogen. If you talk about fourth, that is ethanol, it has what? It has a 3 alpha hydrogen. And again, for five, it has 0 alpha hydrogen. So what they have asked, which do not undergo, which do not undergo. Sir, how long will be this class? Around 1 hour, 1 hour, around 1 hour, 10 minutes. You guys will be free at 10 p.m. 10 p.m., 5 minutes or 10 minutes, you guys will be free. Okay? And with in this time frame, we will cover the complete syllabus. Okay, complete syllabus, MCQs from the complete syllabus of organic chemistry. So, which do not go under what? Which do not go under aldol condensation. So the compounds that do have the 0 alpha hydrogen, that is first, second, third, and fifth. So third and fourth only, third and fifth only, no, second, third, and fifth. So remember one point, if you have to go for the aldol condensation, they must contain what? They must contain the alpha hydrogen. Okay. So the correct option will be your option number D, that is 2, 3, and 5. Okay. 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 Now, next question. So this was the concept. Which of the following molecules is least resonance stabilized? Okay, so we have to find least resonance stabilized. Okay, simple thing. Just go for what? Just go for aromaticity. Just go for what? Aromaticity. This is aromatic. These are all the A, B, C are aromatic. And if you talk about D, yes, I'm getting a right answer in the chat box. Yes, Dhruv. Yes, 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 Dhruv, Srishti, you guys are good. You guys have given the right answers. That's all. If we talk about the option in the D, this is what? This have a cross conjugation resonance and it have a least resonance. It will have what? It will have a least resonance. Why? Because it is a non-aromatic compound. So if you remember the concept of aromaticity, then you will be able to solve the question. So the correct option will be what? The correct option will be option number D. And why the aromatic compounds are highly stable? Because according to the Huckel's, they must have what? They must have 4n plus 2 pi electrons, and for a planar and cyclic compound to be aromatic. So rules for aromaticity, this is very, very important, guys. You guys can expect a one question directly from this point of view, that what are the rules for the aromaticity. They directly can ask questions in the examination from this aromatic question. The first one is they must be what? It must be cyclic. The compound must be cyclic. Second, every atom in the ring must be what? Must have a conjugated double bond system must be present. And third, the molecule should be what? Planar, and the carbon should always wish to have which hybridization? The carbon should be of sp2 hybridization. And fourth, the molecule have 4n plus 2 pi electrons. So this is the concept of aromaticity, and the Huckel rule is very, very important for your examination. So remember this slide. Now, next question. Sir, how to check Huckel rule in this kind of question? That's what I'm saying, that you have to find this point, like the compound must be cyclic. The second point is every atom in the ring must be conjugated. That is, conjugated means there must be alternate double bond must be present. And the third point is the molecule must be planar. The molecule must be what? The molecule must be planar. And the fourth point is the molecule must have 4n plus 2 pi electron. The 4n plus 2 pi electrons. If you see in this point, just go for this. Here, conjugation, alternate double bond is present. In this, alternate double bond is present. In this, alternate double bond is present. But here, this is what? But alternate double bond must be present like here, but it is not present here. So that's why it will not be aromatic. So don't get confused. Just remember 3 points and 3 points, and you will be able to understand this. Now, next question. Question number 9. What the question number 9 is saying that tautomerization is that type of isomerization which involve what? Tautomerization means what? Tautomerization means keto and enol conversion. The conversion of keto form to enol form. Simple. Change in the position of hydrogen atom only. There will be the position of change in position of hydrogen atom, but if they are saying that change in the position of hydrogen atom only, no, this only makes it the wrong option. Change in the position of pi bond only, no, only, no, is that wrong word. Change in the position of hydrogen atom as well as change in the position of pi bond, yes, this will be the right answer. There should be change in the position of hydrogen as well as change in the position of pi bond, both, because if it is converting from the keto to enol form, then there will be the change in what? There will be the change in hydrogen atom, and also there will be the change in pi bond. No change in the position of hydrogen. No, no, no. There will be the change. So the correct option will be your option number C, that is change in the position of hydrogen atom as well as change in the position of pi bond. Okay, so tautomerism is a phenomenon where a single chemical compound tends to exist in two or more interconvertible structure. Like if there is, it is from the keto to enol form. So what is happening here? Here, if we see that the pi bond is shifting from here to here, and also there is an addition of hydrogen. So there is a position changing position of hydrogen as well as changing position of pi bond. Okay, next question. Protic and aprotic solvents are very similar. So protic means what? Protic means, it means that protic means here protons are present. If protons are present, it means that the compound is what? Solvent is protein. Protic, if protons are absent, it means that they have protein. So all the game is what? The presence and absence of proton. So here, polarity, no. Ionizable hydrogen, yes. Protons are what? Protons are you? Ionizable hydrogen. Ability to stabilize an ion. So the correct option will be what? Ionizable hydrogen. That is protons. If the protons are present, it means that the solution will be otherwise. Okay, simple. So the correct option will be option number B, that is ionizable hydrogen. Okay. So this is the what? Hydrogen at least one hydrogen atom for the protic solvent, no hydrogen for aprotic solvent. So these are basic difference between protic and aprotic solvent. Next question, question number 11. What the question number 11 is saying, which of the following does not contain any asymmetric carbon but can show the enantiomerism? Okay, so the system is saying, the question is saying that whether they don't contain any asymmetric carbon, but they will what? They will show the enantiomer. So the first option is what? The first option is your lactic acid, and it consists of what? It consists of your chiral carbon. It consists of your chiral carbon. Lactic acid consists of your chiral carbon. When 3-pentadiene, it have no chiral carbon is present, but it also don't show the what? It also don't show the enantiomerism. The condition should be true, that it does not contain any asymmetric carbon, and also it will enantiomerism. So both first and second will not be there. Titric acid, yes, in titric acid, two chiral centers are present, so also it will not answer. But if we talk about 2,3-pentadiene, that is alkene system, it shows the enantiomerism, and it also don't have a chiral carbon center. So the correct option will be what? If we talk about like this 2,3-pentadiene, so the correct option will be what? The correct option will be option number D will be the right answer. Okay. This like this. Lactic acid, 1,3-pentadiene, tartric acid, 2,3-pentadiene. Next question. Arrange the compound this type of concepts are questions they ask, there are high probability that they can ask these type of simple questions like what are the reactivity of towards the nucleophilic addition reaction, towards the nucleophilic substitution reaction, and what are their what acidity and basicity. So understand this question. So arrange the compound in decreasing order of the reactivity towards what? Towards the nucleophilic addition reaction. See, towards the nucleophilic addition reaction. If we talk about what? If we talk about your first option is your acid chloride. The first one is your what? The first one is your acid chloride. It will like this. See, here chlorine will be there and it will like this. The second one is your aldehyde. The second one is your aldehyde, that is C double bond. Oh, just give me a second. The second one is aldehyde, that is C double bond at one H, like CHO. The fourth one is your what? The fourth one is your ketone. It will like this C, then it will R and R. And the fourth one, that is last one is your what? Last one is your ester. So if we talk about this, it will like double bond. Here it will R and oxygen. So this oxygen have what? This oxygen have the free radical, and which will make its what? Which will make it due to which then stabilization will takes place. Then after that conjugation stabilization will takes place, which make it was, which make it less stable, which make it the least stable. So option fourth at a least stable. So this no. Fourth at the least stable, that is either first A and B will be the right answer. And after that, fourth, then we will move towards the then the second one is what? After ester, then ketone, then what? Then aldehyde and then acid chloride. So the correct option will be your option number A will be the right answer. Okay, so the correct option will what? The correct option will be your option number A. Okay. So chlorine atom, is saying that chlorine atom withdraw the electron density from carbonyl atom, alkyl group and anoxic group and adds the electron density to the carbonyl atoms, and the decreasing order is what? Chloride is aldehyde and ketone acid. Okay, so the correct option will was your option number one will be the right answer. Okay, next question. Arrange the following in the decreasing order of their what? Decreasing order of their acidic strength. For the acidity function, what we have understand that acidic strength, that is what? Is directly proportional to minus I group, and it is inversely proportional to F plus I group. So just understand which group is your minus I and which group is your plus one plus I, and you will be able to answer this. If you talk about like CH2OH, here CH2 group is attached, here fluorine is attached, here chlorine is attached. So CH2 is what? The CH2 is what? The HCH2 is your plus I group. So it will have the what? It will have the least acidic strength. So first at the last. So everyone in every option first is at last. Now fluorine and chlorine is are there. So both fluorine and chlorine are what? Both fluorine and chlorine are the minus I group, and both will increase the acidic strength. So which will increase more? We know that the electronegativity of electronegativity of fluorine is more than electronegativity of chlorine. So which will increase the acidic strength more? Fluorine or chlorine? Fluorine. So the first that we have to, the first is what? The first is your second, then after that third, then after the first. So option number B will be the right answer, like second, third, and first. Okay, simple concept. Just remember one thing: acidic strength is directly proportional to minus I group, and it is inversely proportional to plus I group. So CH2 is your plus I group, and both CF3 and CaCl3 is your minus I group. And since fluorine have a higher electronegativity, so it will increase the acidic strength more as compared to the chlorine. That's why the second will be, then third, then first. So the correct option was your option number B will be the right answer. Okay. Next question. Question number 14. What the question number 14 is saying, bromobenzene upon reaction with Br2 and Fe, it gives what? It gives 1,4-dibromobenzene as the major product. Okay. The first option is okay. Now, in bromobenzene, the inductive effect of the bromo group is more dominant. They have it in the decrease order. Okay, so bromo group is more dominant than the mesomeric effect in directing the incoming what? Incoming electron. You should have a focus on the symbols, like what the symbols they have, and you should focus on that. Okay. So the first statement is what? Bromobenzene upon reaction with Br2Fe3 gives 1,4-dibromobenzene as the major product. Okay. And the first point is saying that, like, simple, if we talk about like bromobenzene, simple is what? Simple is your bromobenzene. And if it reacts with what? If it reacts with bromine, then it will give what? Then it will give bromine, and again bromine. Yes. So 1,4-dibromine as a major product. Simple. So the correct assertion is all right. But the reason is saying what? The reason is saying that in bromobenzene, the inductive effect of the bromo group is more dominant than the mesomeric effect. directing the incoming electrophile. No, here what? Here the mesomeric effect will dominate, not inductive effect. So your first option is true, but the second option is what? The second option is your false. So the option number C, that is statement 1 is true, but the statement 2 is false, will be the right answer. That is option number 3. Statement 3 will be the right answer. That's why. Next question. The number of atoms present in each bridge. Okay, so there are how many bridges are there? 3 bridges. The first one is like this one, then second and third. Okay, so if we talk about in number of first bridge, how many atoms are present? So 1, 2, 3. So in first bridge, 3 is present. If we talk about in the second bridge, what? How many present? 1 is present in second bridge. In second bridge, how many atoms are present? 1 atom is present in second bridge. So, and in third bridge, is there any atom are present? No, single, 0. 310 will be the right answer. And if we had to nomenclate, if we had to give the nomenclature, what is there? So nomenclature will what? Nomenclature will your bicyclo, since it is bicyclo, and 3, 2, 1, and total how many atoms are there? 6. So bicyclo 3, 2, 1 hexane, that is bicyclo hexane will be the right answer. Bicyclo 3, 2, 1 hexane will be the right answer. So the correct option is your what? 3, 1, 3, 2, 1. No, 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 guys. No, 321. No, 321. It's what? 310. There, single atom, no atom. So the correct is bicyclo 310 will be the right answer. That is option number B will be the right answer. Okay. Let's move on to the next question. What is the question number 16 is saying? Okay, so for question number 16, very simple question is there, and yet most of the students get confused. Which of the following compounds are erythroenantiomers? What are the which compounds are the erythroenantiomers? Okay, so the first is, if we talk about for the erythroenantiomers, two compounds, two conditions are there. The first one is symmetry should be absent. For the erythroenantiomers, symmetry should be absent and same group on continuous chiral carbon should be there. Symmetry should be absent and same group on the continuous carbon. If it like option A, this one is what? HH, same group on the continuous carbon. So it will what? It will what? It will your erythroform. Then here again different and symmetry is present. So it's not symmetry is not present, but different groups are there. So it is what? It is your three form. Again, this third one is what? The third one is again your three form, and the fourth one is what? The fourth one is your enantiomer form. The fourth one is enantiomer form. So which of the following are erythrophores? First and fourth. The first and fourth are your what? The first and fourth are your enantiomers. Okay. So the correct option will what? The correct option will option number B, that is first and fourth the enantiomer. Okay. So remember two conditions. For the enantiomer, two conditions are there. The first one is what? The first one is symmetry should be absent. The first one is symmetry should be absent. And the second point is what? There should be the same group of on continuous chiral carbon. There should be one. There should be same group on continuous chiral carbon. That's okay. So the correct option will what? The correct option will be option number B. That is first and fourth is your enantiomer form, and remaining are three of them. Okay. So erythroenantiomers, and this was what. Next question. Question number 17. What the question number 17 is saying? All the hydrogen atoms in butadiene lie in one place, one plane. Sorry, they are saying that all these are lie in one plane. Is it correct or not? Let's understand. See what they are saying, that but2e. So simple, just make a but2e. Simple structure like C double bond C. Okay, but2e. You have to remember form like so. If it is a hydrogen will be there, and again then carbon, one carbon group will be there and another will be there. So this till this structure, they are in a same plane. Till this structure, if you talk, they are in same plane. But the hydrogen that are attached to these carbons like this and this carbon, they will what? They will lie in different planes. Which planes? They will lie in, they will lie in different planes. This like this, and they will lie in different planes. So if we talk about the structure till this, if we talk the structure till then this will be in the same plane. But after that, these hydrogens must lie in different planes. So your option A will be what? Your option A will be the wrong. The second option is saying all the carbon atoms are sp2 hybrids. So is it correct? sp2, okay, like if you talk about this, these two carbons, these are sp2 hybridized, but this is what? This is your sp3, and again this is also your sp3. All are not sp2 hybridized. The two carbons are sp2 hybridized, whether the two carbons are sp3 hybridized. So the correct option will be both A and B are wrong. Option A is also wrong. Option B is also wrong, and the reason why they are right. The correct option will be option number D, that is both A and R are false. Simple. So it is not necessary that every time the options must be correct. Sometimes they give us the wrong options also. trick you guys to check your assessment. There is a point. So both assertion and reason are false for this question. Okay. Next question. Dehydration of alcohol is mediated by the formation of what? So dehydration of alcohol means what? Means the removal of water from the alcohol is mediated by the formation of what? Free radical carbocation, carbon and carbon. Very simple question. So I don't think you guys even gave a single second in this question. Just make little chat box more active. Share your answers or questions in the chat box. If you guys are facing any issues or any point, or if you share your answers, and you can also thing in the chat box. Okay, I'm getting the right answer in the chat box. Okay, this person is SSMB29 movie. Nice name, bhai. The correct option will be carbocation. So dehydration of alcohol is mediated by what? They mediated by the formation, that's intermediate that form in the dehydration of alcohol is what? Your carbocation will be the right answer. Yes, Dhruv, you are also right. So the correct option will be your option number B, that is the carbocation. Okay. Now, so this is the dehydration. Three step. The first one is the formation of what? Protonated alcohol. After that, formation of carbocation, and at the end there will be the formation of what? There will be the formation of alkene. Okay. So let's move on to the next question. So it's question number 19. What is the question number 19 is saying? Very simple question. That is what? Which of the following ethers cannot be prepared by the Williamson ether synthesis? Okay. So Williamson ether synthesis is what? Williamson ether synthesis is your type of which type of reaction? It is a type of SN2 reaction. Williamson ether synthesis is type of SN2 reaction, and they have said that which cannot be prepared. So like if you talk about what? Isopropyl ether, ethyl ether, yes, this can be prepared. Tertiary butyl methyl ether, yes, it can be prepared. Anisole or tertiary butyl phenyl ether. So which cannot be prepared? Tertiary butyl phenyl ether. This cannot be prepared by what? This cannot be prepared by your Williamson ether synthesis. Okay. So the correct option will be your option number C, that is Williamson ether synthesis. Tertiary butyl phenyl ether, because both side of because the phenyl and butyl both are alkyl groups. So the correct option will be your option number C, that is tertiary butyl phenyl ether. No, you guys got confused. Most of the answers, most of the questions getting answer B. No, the correct option will be your option number C. Next question. Next question is what? The elimination of HX from the alkyl halide forms an alkene. HX from the alkyl halide is what forms of alkene. The order of the elimination of the reactions. Just remember one point. Just remember one point. Whether it should be the even elimination or it should the E2 elimination. Whether it is even or E2, the always the order of the elimination of reaction was the always the order will be what? The order will be what? 3 degree, then 2 degree, then 1 degree. Always, whether it is E1 or E2, the correct option order will always 3 degree, 2 degree, and 1 degree for the elimination. So the 3 degree, 2 degree, yes, the first option is your first option is right answer. One, no. So remember this point. E1, E2, any elimination, 3 degree, 2 degree, then 1 degree. Remember this point, and you will always get the elimination answers right in the exams. Okay. Next question. Again, the question number 21. What the question number 21 is saying that in pinacol and pinacolone rearrangement, the shift of alkyl group is what? So simply what is the pinacol and pinacolone rearrangement? Let's understand this one. Okay. So this is what? If we talk about this, make the structure of pinacol, that is CS3, C, one more CS3 is there, then CS3, C, CS3, OH and OH. Okay. So this is your what? This is your pinacol structure. So this is your pinacol, and when formation of rearrangement in pinacolone, by removing the H2O and rearrangement, what we form? We form what? We form the CH3, C, double bond O, then C, one more CH3, one more CH3, and here CH3. So what happens here? Just this carbon, this CH3 shifts at what? This CH3 bond, the bond is shifting as this. So the bond was shifting what? That just next to it. That is which type of shift is there? It is 1-2 shift. Yes, you guys are right. Like Dhruv, yes, you have also given a right answer. SSM, yes, you are also right. So I'm getting a lot of right answer in the chat box. So the correct option will be what? It gives us what? It gives us 1-2 shift. Simple. Pinacol rearrangement gives us 1-2 shift. That is option number A will be the right answer. Okay. So this was all that we have discussed. Next question. Among the following given compounds, the decreasing order of their acidity. What will be the decreasing order of their acidity? So, in order to what? If we talk about this fourth, there are what? So the OH group is what? OH group is your minus I group. OH group is what? OH group is your minus I group. OH group is your minus I group. So here, what is there? There is a one minus I group is here. Here also one minus I group. But if we talk about the what? Then OH group also ortho. If no, no, OH is what? OH is your plus M. Sorry. Just remember one thing. This is your benzoic acid. If we have to find what? We have to find out increasing order of the acidity. Just remember one. So in case of benzoic acid, I will take check. I will tell you guys a simple trick for the benzoic acid. What is this? Just remember one more point. If there is ortho substituted benzoic acid, if there is what? If there is ortho substituted benzoic acid, yes, I got a right answer in the chat box. Yes, guys, you are right. There will be what? There will be the ortho effect. That is the ortho substituted benzoic acid will be always what? Will be always of the greater acidity. That is for the ortho substituted benzoic acid is always more for what? For your due to the effect which is known as ortho effect. And also, as we have discussed, that acidic strength is directly proportional to minus I group and minus R group, and inversely proportional to what? Plus I and plus R group. But for the ortho substituted, it will say what? Ortho effect. Okay, so the correct order will what? The correct order will be your option number D. That is the most one is what? The most will be your fourth. Then because we have to find what? We have to find the decreasing order. The least one what? The least one will be your fourth. Then second. Then your first. Then your okay. So the correct option will what? The correct option will be option number D will be the right answer. Okay. Next question. One pi bond is broken in the reactant and one sigma bond is formed. One pi bond gets broken and one new sigma bond is formed in the product. The type of intramolecular reaction is okay. Simple reaction, very simple. One pi bond is getting broken and what? One sigma bond is getting formed. So the first one is your what? The first form is your form. So in code form, if we talk about there is a no net change in code form, there is a what? There is no net change in any formation like in pi or sigma breaking. And sigma tropic, if you talk about the what? If you talk about the sigma tropic, then it will report. Then cope is a part of a sigma tropic bond. Cope is what? Cope is a part of the sigma tropic bond. And if you talk about the electrocyclic reaction, yes, electrocyclic reaction very simple. What happens in electrocyclic reaction? This like this. The structures are like this, and it will result in formation of what? This bond will shift towards this, and this bond will shift towards this, and which will result in formation of what? Which will result in formation of cyclic structure. So simple. So here what is happening? One sigma bond is forming and one pi bond is breaking. Like this pi bond is breaking and result in formation of one new sigma bond. So this is what? This will be your electrocyclic reaction. The correct option will be what? The correct option will be option number C is the right answer. That is electrocyclic reactions. Okay. So electrocyclic reactions are the class of the what? Class of the pericyclic reaction in which a conjugated polyenes interconverts with unsaturated cyclic effect. Okay, so in such unsaturated cyclic effect, compounds containing the one less carbon, which will result in containing what? Containing of one less carbon double bond than polyenes. So this was all formation of a cyclic compound, which where the formation of what? Formation of one one pi bond was breaking and one sigma bond was getting formed. Okay. Next question, that is what we have the question number 24. Very simple question, and I don't think you guys even think twice for this question, and you will be able to answer it very correctly. So what the question number 24 is saying, which set of hybridization? There are compounds C1, C2, and N, and we have to give what? We have to give the correct set of hybridization for this. Okay, the correct set of hybridization. Simple. For the C1 carbon and then for the C2 carbon and then for the nitrogen carbon. Okay. So for C1, all are made. C1 will be your what? The C1 will be your sp2 hybridized. This C2 will also be your sp2 hybridized, and this nitrogen will also be your sp2 hybridized. So C1, C2, and nitrogen all are sp2 hybridized. So C1 sp2, C2 sp2, and nitrogen will be sp2. So the correct option will be your option number C will be your all are sp2 hybridized, C1, C2, and nitrogen. So the correct option will be your option number 3, sp2 hybridized. Okay. Next question. Which compound is most basic? Simple question. Which compound is your most basic compound? And so NH2, again NH2, NH2 and CF3 is there and CS3 is there. Okay. So how to find the basicity is by the donation of proton. So the correct option will what? Which one will be the most basic? I don't think you guys should think twice for this also. Which will be more basic? Simple. Your option number A, that is cyclic ring containing the NH2 will be the most basic compound. The correct option will what? The correct option will be option number A. That is NH2 will be the most basic. Simple question. Stefan's reduction. As I have told, the name reactions are very, very, very important. The name reaction is what? The name reaction is very important. So I have a simple trick for you for the Stefan reaction. What is the Stefan reaction? Simple. Stefan reaction is simple. That's it is a conversion of cyanide. That is RCCN in the presence of what? In the presence of SnCl2 and what? SCl. It's in the presence of SnCl2 and SCl, and it will form what? It will form the RC. Just remember, just remember, Stefan is very shana person. Stefan is what? Stefan is very shana person. Okay? Stefan is very shana person. Simple. What does Stefan mean? Sana. Stefan is very shana person, and he is making what? He is making your aldehyde. Stefan is very shana and he is making aldehyde. Simple. Stefan is what? Stefan is very shana, that is cyanide, and he is making what? He is making your aldehyde. So Stefan shana is making aldehyde. Simple. In the presence of what? In the presence of SnCl2 and HCl. In the presence of sir, yes, bro. That's why the question have asked about the basicity, not about the acidity. So the correct option will what? The concentration of solution of ClCl3 reacts with phenol in Stefan what? In this reaction, cyanides are what? The cyanides are reduced to aldehyde. What I have told that Stefan is very shana and it is getting reduced to what? It is getting reduced to aldehyde. Stefan is converting to the and cyanide is getting converted into the aldehyde in the presence of Cl2 and acid. Okay. So the correct option will be your option number B will be the right answer. Okay. So this is what this was an alkyl cyanide. It is converted into the aldehyde, and here this imine hydrochloride is getting formed as an intermediate product. Okay. Next question. So aldol condensation. Again, simple question of the aldol condensation. So what is the aldol condensation is what? So if you talk about the self condensation of aldehyde only having at least one alpha hydrogen, self only again there if only is there, then only is changing your games. Not aldol condensation is only for aldehyde. No, it is for aldehyde and ketones both. So self condensation of aldehyde only, no. Self condensation of ketone only, no. Self condensation of both aldehyde and ketones having at least one alpha hydrogen. For the aldol condensation, we have seen that they must contain what? They must contain a alpha hydrogen. And self condensation of both aldehyde, no alpha bond. They must contain a alpha. So which will be the right answer? Option number C will be the right answer. That is self-condensation of both aldehyde and ketones, and it must having at least one alpha hydrogen. Okay. So this is what about the aldol condensation. In this chemical reaction, two or more molecules of the same or different carbonyl compound containing alpha hydrogen unite together in the presence of what? Dilute bases like NOH, BOH, and the compounds that are formed is known as what? Known as aldol. Okay. Next question, that is the question number what? The question number 28. Quinoline. The question number 28 is saying what? Quinoline undergoes the nucleophilic substitution reaction when heated with NaNH2. Okay, so quinoline is getting, yes, alpha hydrogen is necessary. Yes, Dhruv, you're right. Alpha hydrogen is necessary. Okay, so quinoline is saying that there is a nucleophilic substitution reaction with quinoline with NaNH2. So there is one name for this reaction. This reaction is known as what? This reaction is known as Tichy-Babin reaction. This reaction is known as Tichy-Babin reaction. So if we talk about for the quinoline portion, if it is NS, the NSR of the quinoline, it most predominantly will take place at what? It will takes at the NSR of the quinoline is takes at the second position. And if you talk about the ESR for the quinoline, that is electrophilic substitution reaction, it will takes at what? It will takes at the carbon fifth and carbon eighth. And if we which carbon have the most predominant? The carbon fifth will have the predominant, but there is one exception. In case of sulfonation, the major product will be your C8 form. Otherwise, in remaining all cases, the major product will be your C form, in which one? In the ESR. But here they have asked about the nucleophilic substitution reaction. So most predominant form of this reaction will what? This your NSR will be option number for the two substituted. That is 2-amino quinoline will be the right answer. 3, 4, no, 5 is yes, 5 for your ESR, not for NSR. So the correct option will be what? The correct option will be option number A. And this reaction is known as what? This reaction is known as what? Tichy-Babin reaction. So for the heterochemistry, just remember one. Remember the active position of all the compounds, because active position is the just the most important question from their active position, from which is the active position for any particular heterochemistry. Okay, so like any particular compound, the active position in active chemistry is very, very important. Okay, now let's move on to the next question. That is, yes, nucleophilic substitution reaction. Again, this is electrophilic substitution reaction on imidazole. So what is the structure of imidazole if you are trying like this? So this is what? This is your imidazole. This is your imidazole. And what is the ESR in imidazole? Okay. So if we give the position number like from 1, then 2, then 3, then 4, and then 5. So for ESR, which position is highly active? This, that is fourth and fifth is highly active. And out of that, the most suitable position is position number 5. For the ESR in imidazole, fourth and fifth position are there, but for both of them, position is more active. So here C4, C5, yes. C6, no, 6, yeah, they don't have 6 and 7 carbon. They only have 4 and 5. So C4 and C5 will be the right answer. So the correct option will be your option number A, that is C4 and C5 will be the right answer. So next question. For which of the following reaction, what for the given reaction, what is A? Okay, so we have to find what? We have to find reactant. Simple thing. C6H5Br HNO3 H2SO4 C65H5NO2Br. No, no, no. Okay. So the correct option for this question will what? C6H5Br. Like if you talk about like this, Br will be there. And since what? Since Br is what? Br is ortho para-directing group. So this will get attached to its ortho group. So the correct option will be option number A will be the right answer. And it is a nitration in which HNO3 and H2SO4 will present. So the correct option will be your option number A will be the right answer. Next question, 31. Again, very simple question. Which one of the following compound is undergoes the predominantly SN2 reaction with aqueous NOH in a polar aprotic solvent? SN1 reaction, SN2 reaction in aqueous medium with polar aprotic solvent. Simple. If we talk about what? If we talk about A, then in all Br, Br. Okay, so in all option, we have to do what? For for this the SN2 reaction, this bromine has to be removed. In all the options, this bromine has to be removed and should have less electron density. And when will be this bromine will remove? When this CH2 will have the less electron density, then this bromine will remove. So this will be the simple concept for this reaction. So if you talk about the first option, that this is what? This will increase the electron density. They will do what? They will do increase the electron density, but this will what? This will decreases the electron density. That's why what will be the most suitable, predominantly will the predominantly faster that will go is your option number B. That is NO2 group will go more faster for SN2 reaction under this condition. Okay. Why? Because they have there should be decreased electron density. Okay. Next question, that is as I have told, the rate of SN2 reaction is directly proportional to electron withdrawing group and inversely proportional to electron retention group and donating group. Next question. In the presence of what? In the presence of dibenzoyl peroxide, addition of HBr to 1-butene. Simple, very, very simple question. Addition of HBr to 1-butene. This is this reaction will take place as for which rule? There is one most common rule in the organic chemistry, that is your Markovnikov rule. This reaction will take place with Markovnikov rule. But there is also one opposite form of Markovnikov, that is anti-Markovnikov rule. And anti-Markovnikov rule applies when there is a presence of what? This compound, that is peroxide. So if the Markovnikov rule if it follows, then what will be the product form? Then the product that will be formed will be 1-bromobutane. It follows the Markovnikov rule. But since here what is present? No, no, no. If Markovnikov rule is present, they will form 2-bromobutane. If Markovnikov rule is present, then they will form what? They will form the 2-bromobutane. But here, since peroxide is present, so it will not follow the Markovnikov rule. It will follow what? It will follow the anti-Markovnikov rule. That's why the final product is what? The final product will be your 2-bromobutane will be the your final product. Okay, so the correct option will what? The correct option will be your option number B. Since why? Because they are following the anti-Markovnikov rule. So the correct option will be your 1-bromobutane will be the right answer. Now, next question. So yes, next question. That is phenol. Phenol on reacting with Hinsberg reagent. Phenol, we have to do the reaction of phenol with Hinsberg reaction. So what is the Hinsberg reaction? Hinsberg reaction is benzene sulfonyl chloride. What is the Hinsberg reaction? Hinsberg's reagent is benzene sulfonyl chloride. And how? Let's do, if we draw it like this, the structure of benzene sulfonyl chloride will like this. S double bond O, double bond O, chlorine. So this is your benzene sulfonyl chloride, and we have to react it with what? We have to react it what? We have to react it with phenol. Simple. And this will result in formation of what? Then there will be the removal of the HCl group, like removal of the H and Cl. This H and Cl will be removed, and there will be the formation of what? There will be the formation of a ester. What they will form? They will finally form the compound like this. S double bond O, double bond O. And this will known as what? This will known as your sulfonic ester. This will known as what? Sulfonic ester. So when the phenol react with the Hindenburg reaction, there will be the formation of what? There will be the formation of sulfonic ester. So option number C will be the right answer. That is the sulfonic ester will be the form. Now, next question. When a nucleophile encounters a ketone, the site of attack will what? When a nucleophile is encountering what? Site of is encountering a ketone. So nucleophile is what? Nucleophile is electron rich species. Nucleophile is what? Is electron rich species. And in ketone, the carbonyl carbon is what? The carbonyl carbon is electron deficient. So electron rich species will target the electron deficient electron. What species? So which carbon they will form? They will form attack on the carbonyl carbon, the carbon atom of the carbonyl is carbonyl. The oxygen atom, no oxygen atom is electron rich. Both carbon and oxygen, no attack. Attack will occur at the carbonyl atom of what? The carbon atom of the carbonyl compound. So the correct option will what? The correct option will be your option number A, that is the carbon atom of the carbonyl. Next question. The question number 35. The question number 35 is saying what? The question number 35 is saying that the preparation of an ethane by the electrolysis. Preparation of an ethane by the electrolysis of aqueous solution of potassium acetate is called what? So it is what? So we have to aqueous solution of potassium acetate like CS3, C double bond O and OK plus. This is your what? This is your potassium acetate, and if we take a two molecule and due to this it will form what? It will form the ethane plus CO2, and this is what known as what? This is known as your coal-base synthesis or coal-base electrolysis. Either coal-base synthesis or coal-base electrolysis. Okay. So the correct option will what? The correct option will be your option number C. That is, it will form a coal-base synthesis. Okay. Now, next question. That is question number 36. What the question number 36 is saying? Again, a very interesting question, which the increasing order of reactivity of the following compounds towards the alkyl halide is. So we have to find the increasing order of the reactivity towards the alkyl halide. Okay. So if we talk about the option number A, there is the group is what? This if you talk about this is plus R group. Plus R group here is there. And if we talk about the B, there is all this plus R here, plus R and minus R groups are there. If in case of A, there is what? Okay, just give me a second. Okay. The correct order for this word, what? The most accurate will be what? The first will be what? The first will be your D. The most that will go is your D. And after that, what will go? After that, there will be C. And after that, what? After that, E. And after that, B will be the right. Because since if you talk about why C, since D, there is only plus R is there. In D, which is there, plus R is there in D. In C, there is a plus R as well as the minus R in C. And if you talk about in B, also there are two minus R groups in B. One is there and one is there. There are two minus R groups, and here in single minus. So what will be the right answer? The right answer will be your option number. Which will be the right answer? Option number B will be the right answer. The option number B. Since alkyl halide, that is CS3, is worse and more electron rich and more charged. So the correct option will be your option number B will be the right answer. Okay, that is this will be the okay. So this will be the increasing order towards the alkyl. Next question, that is what? The delocalization of a sigma electron in hyperconjugation. The delocalization of what? Delocalization of a sigma electron in hyperconjugation is hyperconjugation. The delocalization of pi electron is what? The delocalization of pi electron is resonance, and permanent partial displacement of sigma electron is what? Is the active effect. So if we talk about this, so yes, delocalization of sigma electron is what? Hyperconjugation. Yes, in hyperconjugation there will be what? There will be the delocalization of sigma electron. If we talk about the pi electron, the delocalization of the pi electron is what? Is resonance. And in permanent partial displacement of sigma electron is what? Is your inductive effect. Permanent partial displacement. Yes. So all 1, 2, 3, all are your right. Option 1, 2, 3 are the correct. Okay. So the correct option will be option number D. That is all 1, 2, and 3 is correct. Okay. Now, next question, that is 30. Question number 38 saying which of the following compound will yield what? 2,3-pentane on reductive ozonolysis. So which compound will yield? So the first one is what? The first one is your 2,3-pentane diene. So initially, what was the end product that is forming? The end product that is forming is what? CS3, C double bond O, C double bond O, CS3 and CS2 and one CS3. So this is the end product that is forming. What? That is 2,3-pentane diene is forming. So what will be the initial product that is formed? So since there are 2 double bond oxygen is there. So there must be what? There must be a in alkyne group that will form this. So what should be the initial product? It is this C triple bond C, CH2 and CH3. So like in first reduction, there this one bond will break and this will form this, and after that one more pi bond will move towards and it will form like this. So what will be there? That is pentyne. That is 2 pentyne group will be there. So the correct option will what? The correct option will be your option number D, that is 2 pentyne group, and on reduction, this compound on reductive ozonolysis, this 2 pentyne will form what? 2 pentyne will form 2,3-butane dione. Since 2 oxygen groups were adding, so there must be 2 pi bond that should contain these oxygen groups. So that's why the right answer will go. The right answer will option number D, that is 2 pentyne. Okay. Now, next question. So 39, the increasing order of the rate of SCN addition to the compound is what? Why? So in order to add the addition, there should be what? There should be the less stabilized compound. So more the stabilization in the compound, less with the addition. So if you talk about the option number C, there is what? There is one phenyl group is there, and one phenyl group is there. There must be resonance and stabilization. So this should come. This should be less susceptible for the addition of SCN. And if we talk about this, there are two phenyl group is there. So two phenyl group means more conjugation and more stabilization. So D must be added. D must be what? D must be the increasing order. So for the increasing order, what? D must be at last. And after D, there will be what? There will be C. And after that, what? After that, there will be B. Then at that, there will be. So the correct option will be what? D, C, B, A will be right. Why D and C at the last? Because of the phenyl group, that is benzene ring. So the correct option will be option number D. Next question. Arrange the following in the decreasing order of the rate of what? Decreasing order of the rate of electrophilic aromatic substitution. So in electrophilic aromatic substitution, if we talk about this first compound, so in first what? So we have to find it on the decreasing order. So first there is plus R group is there will be what? There will be the plus R effect. And if we talk about in this, there is what? In second, there is what? There is minus R. And if you talk about in the third, what? There is plus R. This will show what? This will show your minus R effect, and whereas this will show your minus I effect. So making it more electron deficient, resulting making it what? Making it more electron deficient, and we have to find the electrophilic aromatic substitution. So what will be the correct order? The correct order will be what? The correct order will be your first, then after that second, and then after that third will be the right answer. So option number A will be the right answer. Okay, so the correct option will be what? The correct option will be option number A will be the right answer. Next question, that is consider the following alcohols, the order of decreasing activity to these alcohol toward the nucleophilic substitution reaction with what? With NS. So NSR means what? NSR means nucleophile, and nucleophile we know it is an electron rich density. So if there is electron withdrawing group is there, if any electron withdrawing group, it will what? It will decreases the NS. If there is electron withdrawing group, they will do what? They will decrease the NS. So if we see this, there is what? There is a bromine and NO2. These two are what? These two are electron withdrawing group. And this will what? This will be your electron donating group. So it will what? Electron donating group will increase the, it will increase. So what? So highest will be what? The highest will be for third, and after that there will be no substitution. So third and then first, third and then first. Okay, but since both bromine and NO2 is what? Those both are electron withdrawing group, and they will decrease the ability for the nucleophilic substitution reaction, which will decrease the more, Br or NO2. Since Br will decrease more as compared to the NO2, that's why then after the what? Then there will be fourth, and then at that there will be second. So the correct option will what? The correct option will be your option number A, that is third, first, fourth, and second. Okay, now. So third, first, fourth, and then second. Now, next question. Acyl group migrates from the phenolic oxygen. Acyl group migrates from the phenolic oxygen to ortho-para position of benzene ring, resulting in the formation of mixture of ortho-para hydroxyketone. This will known as what? This will known as what? So Curtius rearrangement, Fry's rearrangement, Gabriel thermite synthesis, or Leucard rearrangement. Here, what is happening? Acyl group is migrating from the phenolic oxygen to ortho or para position of what? Benzene ring, and resulting in the formation of mixture of ortho para hydroxyketone, and this is known as what? This is known as your Fry's rearrangement. Simple name reaction. The name reaction in organic chemistry is very, very, very important. They can directly ask you questions from the name reaction. So the correct option will be your option number B, that is a Fry's rearrangement. Next question. 2-chloropentane on hallucination with chlorine gives 3-dichloropentane. Initially, 2-chloropentane was there, then hallucination with the chlorine will take place and it will converting into the 2,3-dichloropentane. What will be the structure of free radical species formed? So the free radical in halogenation will take place what? Halogenation will take place with the formation of the free radical, and that free radical will what? That free radical will be sp2 hybridized, and due to that sp2 hybridized, the structure will what? The structure will be trigonal planar. Due to the sp3 hybridization, the structure will be your trigonal planar. So the correct option will be option number B, that is the trigonal planar structure. Okay. Next question, question number 44. What the question number 44 is saying that aryl halides are less reactive. Aryl halides are less reactive toward the nucleophilic substitution reaction as compared to the alkyl halide due to what? Aryl halides are less reactive as compared to alkyl halide. Why? Because they are more stable. And why they are more stable? Because of the presence of what? Because of the presence of the resonance. Because when they are more stable, then their reactivity will be less. And why they are more stable? Because of the presence of the resonance stabilization, due to the resonance stabilization. So the correct option will be your option number B, that is due to the resonance they are highly stable, and that's why they are less reactive. Next question, question number 45. What the question number 45 is saying, among the following compounds, the most acidic compound is what? So we have told you, in case of benzoic acid, there was one effect was there. The first one is your para-nitrophenol. So let's draw all the structures. If you talk about the first one is your what? The first one is your para-nitrophenol. So if you talk about like this will be your phenol, and this will be your nitrophenol. This is what? This is your para-nitrophenol. Next one is, if you talk about the second one is para-hydroxybenzoic acid. So if you talk about this will be your benzoic acid, and this will be OH. This is your para-hydroxybenzoic acid. The third is what? The third one is your ortho-hydroxybenzoic acid. Same. This is your COOH and OH. And the fourth one is para-toluenic acid. So there and CS3. So the first thing, that benzoic acid will be higher. So whether it is orthobenzoic acid or parabenzoic acid, which will be the stronger acid. So we know that if there is ortho group attached at a benzoic acid, then there is effect comes in the existence. That effect is known as what? That effect is known as your ortho effect. And due to that ortho effect, ortho substituted benzoic acid is always more acidic. So the correct option will be your ortho hydroxybenzoic acid. Okay, so let's understand there will be some pK values. Like if you talk about the orthohydroxybenzoic acid, pK value is 2.98, toluenic acid 4.7, para-hydroxybenzoic acid 4.53, and para-nitrophenol pK 7.15. And we know that acidic strength is what? Acidic strength is inversely proportional to your pK value, and it is always inversely proportional to pH value. Lower the pK, that is 2.98, lower will higher will be the acidic strength. So the correct option was what? Ortho substituted benzoic acid, due to the presence of what? Due to the presence of ortho effect. Next question, question number 46. What the question number 46 is saying, the component of the formula like CH3COOCH2 and CHCOOH would be expected to. Okay, so we have to find it. So what will then? Rotate the plane polarized light. The second one is what? Contain the chiral center, contain the three stereo center, and the fourth one is so geometrical isomer. Rotate the plane polarized, it is optically active. No, it is not optically active, so it will not rotate your plane polarized light. Contain the chiral center. No, chiral centers are not there. Contain the three stereo centers? No, only one is there, not three. So the geometrical isomers, yes, it can show the geometrical isomers. So the correct option will be what? The correct option will be your option number D, that is only fourth option is correct, that it can show the geometrical isomerism. So option number D will be the right answer. Okay. So it shows the geometrical isomerism due to the presence of the double bond, but it does not have any chiral carbon. That's why it was optically inactive. And since it is optically inactive, it can't rotate the plane polarized. Okay, so for the geometrical isomerism, there will be what? And for the geometric restriction of the carbon atom, carbon-carbon double bond, this is the necessary condition for the geometrical isomerism. Next question, question number 47. What the question number 47 is saying? Aniline under the acidic medium, when chlorinated, it produces what? In acidic medium, chlorine. Like if you talk about in aniline like this, NH3, NH2, then it is, we have to react to chlorine. So it will form what? It will form, since it is orthopara directing, so it will form first component, it will form like this, NH2 and Cl. In the second that it will form like this, NH2 and one more Cl. So ortho and para both will form. Ortho chloroaniline only ortho will not form, both ortho and para will form. Meta no, para no, mixture of ortho and para. Yes, there will be the mixture will be formed. So the right option will be option number D, that is the mixture of ortho and para chloroaniline will form. So next question. 𝙁 reaction. Okay, 𝙁 reaction is very simple. What in 𝙁 reaction there will be what? There will be the conversion of toluene to benzene. What will happen in 𝙁 reaction? Simple. There will be a what? In 𝙁 reaction there will be a toluene, like a CH3. There is a toluene, and it in presence of what? In presence of the chromic chloride, that is CrO2, Cl2, and CCl4, CH2. Okay, CCl4 and CH2. It will form what? It will form the benzaldehyde. It will form what? It will form the benzaldehyde in form of in toluene gets converted into the benzaldehyde in the presence of chromic chloride. So the correct option will be what? So in 𝙁 reaction, oxidation of toluene to benzaldehyde by chromic chloride सही है. Oxidation of toluene to benzaldehyde by alkaline, no, not alkaline KMnO4. If it in presence of alkaline KMnO4, it will not get converted into the benzaldehyde. It will get converted into what? It will get converted into the benzoic acid. It will not get converted into the benzaldehyde. It will convert into the benzoic acid. Dry distillation of the calcium benzoate. Reaction of benzene with no. So the correct option will be what? Oxidation of toluene in the presence of what? To benzaldehyde in the presence of the chromic chloride. Anything will be full night. No, it will not be full night. We will cover the 50 questions and then we will end. So 𝙁 reaction, then it will converge. Okay. Now next question is what? Which of the following are classified as an aromatic? Which of the following will classified as an aromatic? 1, 2, 3. Triphenyl cyclopropanium cation will it be aromatic? No, it will not be aromatic. The second one is what? The second one is cycloheptatrienyl cation. Yes, if we form the structure like this, this is what? This is the what? The real structure like this, and it will like this. So this, okay. This is what? This is your cycloheptatrienyl cation. Okay. So this is what? This is your aromatic. Pyrrolidine, no, pyrrolidine is not aromatic. And if we talk about aniline, remember one point, either it is 8 aniline or it is 10 aniline. Either it is 8 and 10. Both aniline are always what? Both aniline are always non-aromatic in nature. Either it is 8 or 10. Okay. So the correct option will be your option number C, that is the cycloheptatrienyl cation will be what? These will be your aromatic in nature. Okay. Now next and last question of the today's. Okay. So with this is the last question of today's marathon. Everyone mention whether you guys are able to understand the concepts and how was the today's marathon. Share your feedback in the chat section, guys. Then we will show you the last question. Okay. Everyone share your feedback fast in the chat section. So how was the today's marathon? Okay. Till then we will solve the question. On heating an aliphatic primary amine, there is what? Aliphatic primary amine is heated with the chloroform. The heating of what? Aliphatic primary amine with the chloroform and ethanolic potassium hydroxide, the organic compound is formed. So what was there? There is what? The ethanol like CnRCH2 NH2. This is what? This is your aliphatic primary amine heated with chloroform CHCl3 in presence of what? In presence of KOH, it will result in formation of what? It will result in formation of RC triple bond and then cyanide, and it is known as what? It is known as alkyl isocyanide. It is known as what? It is known as alkyl isocyanide. What is that? It is known as your alkyl isocyanide. Okay. So the correct option will be what? The alkyl isocyanide will be the right answer. Okay. So the correct option will be alkyl isocyanide. Okay. So on heating the aliphatic primary amine with the chloroform and ethanolic potassium hydroxide, the organic compound that is formed is your alkyl isocyanide. RCH2CHCl3, it will form the alkyl isocyanide. Okay. So with this, guys, we have finished the today's marathon, the 50 question from the complete organic chemistry, and I would recommend you guys to go and watch the what? Not only watch the answers of this question, also is focus on the explanation and that explanation that was presented inside the slides. Okay. So with this, thank you everyone for the joining, and just remember, guys, there are only few days remaining in your examination. So focus on revision and also focus on short topics like barristers that are given continuously on the JDC English YouTube channel, and guys will get a what? You guys will do rocking performance in the examination. Okay. So with this, I'm ending the today's session. Thank you everyone. Thank you so much for joining the session, and bye bye. Good night. We will meet in the next session. Till then, thank you.